My name is Chris Hamilton, and I'm very happy to be continuing Grantek's 2019 webinar series around missed opportunities. Today, we're going to be building on missed opportunities in industrial controls with a focus in cybersecurity and network maturity. Cybersecurity is an important focus for missed opportunities because by its nature, it must be baked in or secure by design, as the term goes, and it is very expensive to add later. We'll start off with a little introduction to Grantek's Strategic Initiatives program, and then I'll talk a little bit about how that fits within my group. Then we'll get into the missed opportunities and talk about some things to consider when you encounter them. If you have questions, please enter them into the chat window on the webinar, and our marketing team will forward some of them over to me. If we don't get your question, you can always follow up with us. There'll be an email at the end of the presentation. We'll start today with some background on who I am and why I'm speaking with you today. As I said, my name is Chris Hamilton. I'm the director of Grantek's Industrial IT and Cybersecurity Group. I have over 10 years in controls on automation, 15 years in IT systems architecture and cybersecurity. I'm a member of the MESA Cybersecurity Working Group as a co-chair with Eric Kossman, and also involved in ISA's 62443 working groups, which is the continuation of the ISA 95. Primarily, my day-to-day is consulting. We really strive to bridge the IT and OT gap. It's a term you've probably heard before. And also really increasingly on how to be a good cyber citizen and then what that means in today's landscape as far as ensuring your systems are patched, ensuring you're doing the right thing to better the humanity of the digital world that we live in. So within Grantek, we currently have 3 strategic initiatives. These are areas where we find a very specific market need for different skill sets and focused skill sets. If you listen to Sam Russum, my counterpart's presentation a couple of weeks ago on smart manufacturing, he did a very nice webinar on missed opportunities in smart manufacturing. Safety, another practice we have with Jeff Winter, and then mine, the IT, OT, and cybersecurity group. So what is cybersecurity at Grantek? We are focused on clients' needs, and we are looking at strategies and offering services in order to meet those needs. Our focus primarily is around industrial control systems and enterprise data connectivity with a philosophy of secure by design. So with that, we'll start getting into our missed opportunities within industrial systems. Our first missed opportunity relates to control system monitoring. Most companies, when upgrading control systems or buying new equipment, rarely take advantage of built-in functionality of PLCs, network hardware, etc., that can provide network health and performance data. So knowing that these features are not utilized, but they are built in, why are people not taking advantage? From Grantek's experience, we typically find that most companies, and honestly, most engineers, don't necessarily know about these features, let alone how to leverage them, which means they get overlooked. Although there's nothing wrong with this, it is sure a missed opportunity in order to minimize network troubleshooting times and increase the visibility into what happens on your controls network. I'm sure that everyone would agree that a network issue can cost lots of money, time, and stress. So anything we can do to make this easier, especially if it's a feature built into something you've already bought, should be a no-brainer. You can see on the screen the references that I would use would be SNMP and syslog. Those are very, very common in most controllers and definitely all switching hardware that can be leveraged in order to increase your visibility. Also, there's a tool that Grantek uses called Interview, designed by Panduit. We leverage that with all of our network assessments to provide us a very quick and detailed snapshot of what is going on the shop floor. And that tool is also available for long-term performance and health monitoring. We find it to be quite useful. Our second missed opportunity is around network interface standards. There are many reference documents available. In fact, we'll talk about some of them later, but adapting them for your business is critical to success, especially when working with individuals outside of the technical domain. I have nothing against project managers. They are wonderful people, and sometimes they are not technical. So why not enable them with the tools to ensure vendors provide the right solution for their business, set them up for success? Grantek finds that if a standard is not provided at the beginning of a project, the vendor is going to use what is known to them. And sometimes this is something that won't fit your enterprise very well. And in other cases, it's just something that's plain cheaper. The impact of this is generally that you have less functionality for monitoring tools, which would otherwise help detect threats and assist in root cause analysis. And really, the correction from this is expensive. Hardware must be ripped and replaced. Engineering time must be spent to adapt to a new solution. And possibly retraining must occur on the individuals that need to operate this system. Grantek recommends defining a network interface standard and targeting that at your vendors, OEMs, SIs, etc. Provide this to your project managers in the quoting phase of a project. That way the vendor knows what to spec and you know what to expect. Some examples of when this document may include are listed on the screen. As an example, a recent project where no network interface standard was provided. In fact, it was excluded from the scope, and it resulted in major rework across multiple vendors. The project team ended up scrambling at the commissioning phase to meet the existing timeline. It was delayed by about 2 weeks. The cost impact was around $40,000 on a $500,000 project. So that's nearly 10% of the total project because of a lack of a single document. Panels had to be reworked, hardware had to be rushed to site, and then configurations changed. And in the end, the supportability of the system was sacrificed in order to implement a functional system within the timeline that was required. This was a learning experience for all parties, and it really shows how important alignment between vendors and the client are as the complexity of device interconnection grows. Our third missed opportunity is around access control. Many clients lack a process to prevent unauthorized access, relying on older and simpler methods such as default passwords, shared accounts, etc. We find the reason for this is simply a lack of focus on security, a fear of decreasing the availability of a system by locking out a user. That is really, a key thing. You don't want to lock out a user that needs to bring your system back online. But at the same time, using default passwords and sharing passwords is not the best way to do that. And the third reason we find that the complexity of managing per user account sometimes is looked on unfavorably. But as threats evolve, we see this lead to massively quick spreading malware and crypto worms and other threats that can cause outages and permanent loss of data. It also prevents a true audit trail when you lack this in order to that would be beneficial in identifying areas for improvement after an outage. If you have everybody using one password or one account, it's very difficult and near impossible to figure out who to talk to, who to ask, what happened, how did this traverse from here to there, what's going on. Grantek recommends some simple steps to further march along in your cyber maturity. 1, change the default passwords. 2, change common passwords. Don't reuse passwords. This is unfortunately common within our industry. And 3, in order to manage all of that, use a password manager. This could be something like KeePass, which is a free and open source tool. It could be something like Excel, password protect that Excel document. Anything in this space is going to be better than using default or shared passwords. And then 4thly, work toward a centralized access control system like Active Directory. Grantek has noticed that 100% of our clients have a user directory system at some level. However, only about 3 in 5 of them use this system on their controls level. None of our clients that I am aware of use this for all controls devices, which would support such an authentication system. Vendor remote access is our 4th missed opportunity, and this is a big one. Today, most OEMs and integrators leverage remote access to provide quick support of your systems, Grantek included. However, we find that some clients do not have or do not enforce a standard vendor remote access policy. Sometimes this may be because it is at odds with their corporate IT policies, and sometimes it may be because they just haven't developed one. It also may be because remote access really is relatively new to our industry. And when trying to adapt corporate IT policies, sometimes it may be difficult to attain agreement across all parties in order to provide remote access for OT vendors that is required. And generally, when offered the easy button, something like an E1 or other cell access for direct access to a machine that only that integrator is supporting, then we find our clients are very tempted to take this route. The impact, unfortunately, of allowing this unmanaged access can be very far-reaching. Without a standard vendor remote access policy, Grantek finds, on average, at least 4 different remote access methods into a plant. This is data that we've aggregated over a number of network assessments. So what that means is there are 4 additional vectors into your manufacturing operations that you cannot control. And the interesting thing about this is that when you start out, those machines might not be connected. And the policy may be to keep each vendor supporting their own machine, keep everything separate. However, what we find is if it can be connected, it will be. So later when those machines are interconnected, we've inadvertently allowed vendor A to access vendor B's machine. And that might be okay. That might not be okay. A threat from vendor A can now traverse to vendor B, and the client has no visibility or control over this. And additionally, changing a remote access solution once implemented can be costly depending on the system configuration. It could require re-IP addressing, it could require NAT devicing, and it definitely will require retraining of the support personnel, and it may be disruptive to support. We recommend developing a vendor remote access policy and providing that to those running your projects that in turn can provide to the vendors at the start of a project. And we do recommend working with corporate IT to ensure the requirements of the ICS vendors are attainable in a secure fashion and in compliance with your corporate IT policies. We recommend that any technologies that do not match your policy, such as E1 devices or other tunneling technologies, be refused. Now, there could be a case for sure where an E1 device fits and applies to your policy. I just use that as an example because I simply see those very frequently as an unauthorized or unplanned device placed in for simple access. They certainly can be legitimately used. I've got nothing against E1s. I also pulled some interesting statistics from our service and support group. They are that over 90% of Grantek support contracts today include a client-managed vendor remote access solution. This is built for use by all vendors. In many cases, Grantek helped develop this. This allows SIs, OEMs, and others to have a common entry point controlled by their client. And we really consider this limiting risk for our company and yours. Additionally, in 2018, 90% of Grantek's over 400 support calls were handled completely remotely. So that means that, I'll get into a second, but also less than 5% of Grantek projects are completed in-house with no client connectivity throughout the life of the project. So the vast majority of projects require connectivity to client systems due to the connectivity, complexity of those systems at some point, whether that's design, testing, or otherwise. And we find that most of the support calls can be handled remotely. So this might be apparent by now, but why remote access? The cost savings versus dispatching an engineer to site is huge. It also hugely decreases the time to resolution of an outage. So that Grantek has found that the average support call is decreased from around 4 hours to the majority of them being resolved within 30 minutes. And as I said earlier, 90% of those support calls are resolved purely remotely. So why secure vendor remote access so the client can be controlled? Well, I hope that you can see that the scalability, cost, and control, and thereby the increased security, are paramount to the functional remote support program in today's world. Missed opportunity number 5, the use of next generation tools. So there are a large number of mature ICS focused tools coming to market and available in the market. I've listed some of the major players there. And with a proper network design, following CPWE or other model, these tools can be very, very useful to enable the behavioral and analytics and advance customers' network maturity. Most of the time, we spend doing our day-to-day activities, and it's hard to look past the horizon to see what's coming. With the rapid increase in change in threats in the manufacturing world, it really is now critical to prepare for future threats and continually evaluate your sites against your standards and the maturity model you choose year over year. This is not a once and done activity. This is an ongoing process. Because there was a lack of historical need before connectivity was ubiquitous, and because there is a large cost and some complexity with implementing these solutions, it may seem easier to lag behind the industry with the use of these technologies. Unfortunately, the threats are real, and if you've had a chance to listen to some of my previous webinars on WannaCry and NotPetya and what being a good cyber citizen really means, you'll be aware how fast this landscape is changing. The risks to your business are bigger than ever. Major outages, permanent loss of data, loss of IP. If you're interested, Google companies like Merck, Mondelez, FedEx, Maersk, who are all majorly affected by NotPetya. I'm talking hundreds of millions of dollars affected. These were filed with the SEC because they did affect the company's bottom line in a single quarter. So what do we know today? We see that over half of our new clients do not know where they stand on the top 20 security controls, the SANS top 20. And this is something that we would like to help change. So after going through those, we're going to talk a little bit about what happens when a company is proactive and what happens when a company is reactive. Two examples. So planning ahead. In fact, in any initiative, I say plan for assessments at each site and budget for network design and connectivity improvements when you're implementing another project. So this could be a smart manufacturing initiative. This could be anything that requires more connectivity. Implementing the proper connectivity, it may require detailed analysis. And because the cybersecurity must be integrated into all aspects, you can't really bolt it on later. So what we've seen, unfortunately, in a lot of cases is the quick fix is I need access to those machine counts, the product counts, and the machine running, machine stop code, and a couple of temperature sensors. So we're going to just retrofit that connectivity, either pull it out of the PLC as it is today, throw a point IO out there and throw some new sensors on, but really we're not looking at the big picture, and we're just trying to scramble through to complete the project. And that happens once you've defined a budget, defined a scope, and you're already on to the design and implementation phase, and you find out that you don't have the connectivity you thought you did. That's the reason why we highly recommend performing these assessments at the head of performing these other initiatives. So the missed opportunity there is the design hours you now spend providing a point connectivity solution, and you miss better planning for network of the future, which could lead to design that can be implemented as requirements grow. So you're missing scalability there, you're missing a plan. And even though you have now gathered the data from some devices, the majority of your data remains siloed. So one of the areas that Grantek and some of our partners really felt that this was done correctly was highlighted in a case study called Modernizing a Network Infrastructure. This was a utility company who had a mandate to take all of their PLC 5s and upgrade them to ControlLogix. And that was the simple mandate from on high. What they did, however, is they looked at their system holistically and they said, okay, right now we're on ControlNet. We can buy ControlNet cards for our ControlLogix processors, and we could just reuse the existing hose as it is. Or looking forward, we know that we want to take more of these tags out of Historian. We know that we want to put some cameras and do some more analytics at other places on this site. And we really don't know what the future is of where we're going to go with all of this. And we know that a technology like ControlNet is going to limit that. So what this client did is they seeked out through their partners company, Grantek, that could come out and perform a network site assessment and provide them a team of partners in order to design, deploy, and support this initiative for implementing a new network of the future. And what they found is they have, much better increased visibility and security in that space, as well as expandability. Ethernet is ubiquitous. That is the assumed connectivity means in most all industries today, and the expandability there is almost limitless. So planning for the big picture future state, focus on the business value, simplify architectures, and reduce long-term cost. The benefits are similar, more cost-effective systems. Risks are an increased time. It takes time to do an assessment up front. And the near-term results may be slowed down because of that. But you got to walk before you can run. And at the end of the day, that's going to be a better solution. So the tools, of course, preliminary site assessment, as we discussed, site-wide detailed network design. And the techniques are taking a look at what it is as is today, what it's going to be, doing a gap analysis of how do we get there. Another example, looking at digitization, is really proactively pursuing secure by design principles and promoting a security culture across all departments. So this is a model from SANS that really shows that cybersecurity requires engagement from all levels of leadership in order to be successful. And that takes the executive level all the way down to the technical. On to digitization. So say you're about to execute a project or a project set for digital transformation, and you're putting together your project plans and you're seeking your partners. If you go through the digital maturity exercise but do not properly focus on cybersecurity, then honestly the system will not have the data integrity that you require. For example, what good is an electronic batch record if you can't guarantee the data confidentiality, which means that data might have been accessed by other unauthorized parties, and the integrity, which means, is it even the right data? This is two of the three areas of the CIA triad, which is a very, very basic IT concept that is critical and applicable to many other areas. And really, at this point, your audit trail is broken. So the recommendation is to ensure that you're baking in cybersecurity to your URS. You have a team which can ensure the technologies are used are current. And that includes, so say today, you can buy a Windows 7 system. Windows 7 exits extended support in January of 2020. That is 7 months from now, less than 7 months from now. So does your new system that you're implementing today come with Windows 7? Similarly, many control systems use protocols like Samba version 1. Samba 1 was created in the 90s, and it was a major player in the lateral spread of NotPetya and WannaCry. So, for instance, NotPetya cost Merck more than $310 million USD in a single quarter. Then the vendors, OEMs, and SIs tend to use what they know over what is current, and this is a concern for future-proofing cybersecurity and lifecycle management when performing a risk assessment to show change is low risk in order to include data integrity. So what we're saying there is when you are using the most current technology and you're implementing the best practices, and then later on you need to upgrade an operating system or change out some hardware, then you'll be more likely to prove that that change is low risk to your GMPs, especially around data integrity, and you'll be able to make that change much more easily. So the benefits here are opportunities for a high quality design, implementation, and support, and of course, lower risk of design changes. Caveats, of course, are upfront time and investment, and sometimes confusing or lack of industry accreditation and resources. Some of the tools that Grantek recommends is ISPE, TUV, and Cisco, amongst many others. But really, you'd be looking at company certifications and individual certifications to ensure that whatever the initiative is that you're pursuing, is going to be covered by those skill sets within your partners. So moving on, I always like to include a section around education, standards, and best practices. So what this is, will give you a list of areas you can go for more information, and maybe what your appetite a bit for what is out there as far as industry resources. Taking a step way back in networking, Grantek and pretty much everyone uses the Purdue model, which relates to ISA 95 in your manufacturing environment. And we use that to define ISA 95 to define the capabilities and user requirements. The Purdue networking model defines level 0 through 4, and then the CPWE and others map that to what you're going to implement from a physical and logical design in order to attain the connectivity you require. So over 74% of organizations have adopted ISA 95 to shape their decisions on MES systems. And that really is where we see a lot of growth today. In addition, Cisco, Rockwell, Panduit, Siemens, they all leverage a model very similar to this, if not referencing it directly. Back to the converged plant-wide Ethernet model, the CPWE. This is a Cisco Rockwell validated design that we consider a baseline for any ICS network. And you can see on the right there, you can map the physical and logical layers to show how this is implemented. And really, this gives you the scalability that you're going to require in the future. It also allows for a defense in depth, cell isolation monitoring, and connectivity where required. So you can't really see it too well in the picture because it's quite small, but I do recommend going out and taking a look at it. Basically, we're talking VLANs and cells, isolating devices that don't need to communicate together. That way, any outage or threat or misconfiguration, etc., is really limited just to the cell that it is a part of. You're not going to see a plant-wide outage because of something like that. ISA 95 or 62443. It's the standard for developing an automated interface between enterprise and control systems. And 62443 standard builds on general purpose information such as ISO, IEC 27001 and 2 and others. And this really governs the secure design for industrial control systems, policies, procedures, systems, and components. You can see the breakdown on the right there. And this also, it strives to the same goal as the CPWE in order to provide defense in depth, cell isolation monitoring, connectivity where required, as well as really starting to develop those policies and procedures and higher level functionality over top of these control systems and their communications. Something I mentioned before, but we'll go into a little bit more detail now, is the SANS Top 20, the CIS controls. So what we find is most of our new clients do not know where they sit on this kind of, call it a maturity model. But basically, the idea is you want to start at 1 and move up to 20. And 1 being inventory and control of hardware assets. So in some industries, say food and beverage, we find that the majority of clients do not have a good inventory of hardware and software assets. In a more regulated industry like pharmaceuticals and life sciences, we find that that documentation is readily available, and that's great. We do find, however, that in both of those industries and many other industries, the controlled use of administrative privileges is not well implemented. It may be on some systems, but in classic controls methods, administrative privileges were needed to do a lot of things. Now you look at modern systems today, and with the proper understanding, it is fairly easy to provide a more granular and restricted access to the user accounts or service accounts that are running these automation programs. And really, the use of administrative privileges should be diminished and or eliminated where possible. Once you get out of some of the basic controls and getting into the foundational controls, we're talking about email and web browser protections. People, some of you might be laughing and saying, oh, my controls network doesn't have internet access. Of course, we wouldn't have that. I will tell you that probably 2 out of every 5 clients where we do a network assessment, we find out that there is, in fact, internet access. Maybe the default gateway was removed from the computers, or they didn't set a DNS server. However, from a functional layer 2, you do have access through a router out onto the internet directly with absolutely no control. So the only thing preventing those devices from talking to the world is a misconfiguration, purposefully misconfiguration on the device level. Same thing with malware defenses and data recovery capabilities. These areas are fairly lacking at the endpoint. Sometimes at the enterprise, the malware is going to be much better threat detection. However, that really does not apply to all endpoints, and it should. And I won't go through too much of the rest of it because organizational, as far as application security software, incident response and management. When we're talking, network operations center, and if there's anybody from the oil and gas or some of those, very heavily regulated industries, government sectors, etc., this will be something you're familiar with. If you are in other general manufacturing, it's probably not something that you've had any experience with today. And in my opinion, that is going to change over time, maybe quicker than you hope. But getting ahead of the basic and foundational controls today is going to be critical for when those organizational controls are required. Another tool that I find very, very useful and that Grantek uses is called the CSET. It's the Cybersecurity Evaluation Tool. And this tool is used in major industries. However, outside of the critical industry sectors, it's not all that well known. And really what it is designed to do is a gap analysis and mapping back to the standards chosen. So you pick the standards, you perform the assessment, the questions, and then it gives you kind of a rubric saying, okay, you meet these and you do not meet these. It gives you areas for improvement. It really raises awareness and facilitates discussion on cybersecurity within the organization. It's designed to provide a talking point for improvement. It'll highlight vulnerabilities in the organization's systems, provides recommendations even on ways to address those vulnerabilities. And this is a free tool developed by the U.S. Department of Homeland Security and provided, for free of charge. It's something that I think everybody should be using. It provides a method for systematically to compare, monitor, and improvement of these cyber systems. So that's key, right? Is you go in, you do an assessment, and you have some changes to make. You make those changes. How do you monitor continual improvement? That's something that we do on our production, on our on our output, on our efficiency. But that's something that we also need to be doing on our cyber systems, on our computing systems, on our network systems, etc. Monitor that continual improvement to show that we are increasing our maturity. Another aspect is that it provides a common industry-wide tool for assessing cyber systems. So you can take this tool and use it in life sciences. You can take this tool and use it in power generation. You can use this tool in oil and gas, and you can really take a look and see. Obviously, a lot of the regulations within the more heavily regulated industries aren't going to apply to the other ones, but that common tool allows you to really see where and why one might apply that in the future. Another interesting resource is the European Union Law and Public Documents. So when searching this just for cybersecurity, there are over 800 documents referenced. You can also search for industrial control systems and various other components. This is not just limited to manufacturing, but this is an aggregation of documents that are related to the European Union, which is very, very mature in a lot of ways, especially when we're talking around Industry 4.0, Pharma 4.0, and I highly recommend taking a look at it. So, in summary, learning the industry standards and best practices and using them as a planning and research tool. Even if you are not a technical person, you don't have to be an expert on those standards. You don't even have to really read all 500 pages of the CPWE. That's not what I'm recommending here. What I'm recommending is be familiar with the tools, industries, accreditation bodies that are out there, and be able to kind of ask the right questions to ensure that the partners you're working with are going to be able to deliver the solutions with the quality that you need. So the benefits are education that applies beyond industrial IT, of course, and the caveats really are virtually none unless you hate reading. Some more tools, some references, and really start with the standards to provide a foundation for other research, and then explore from there. So in summary, we have this very, very happy meter here of network maturity. And looking at our top missed opportunities, we have monitoring, network interface standards, access control, managed vendor remote access, and next generation tools. So how those apply in smart manufacturing, in digitization, secure by design, and some of the standards that you can use in order to familiarize yourself with the topics here, and hopefully begin to avoid these these missed opportunities and really find both cost and time savings and improvements in your projects because of that. So with that, I saw one question come in here so far, and there are some others in the chat. So let me get to that. The first question is, what do you recommend for a shared password tool? And do you have best practices around changing access to that tool as an employee leaves? Yes, this is a great question. And it is, not necessarily one that is going to be answered with a simple buy this piece of software or do that, right? What we found is that classically, the easiest thing to do when in a projectized company is leverage something like Excel or KeyPass. So that has the obvious caveat of it can be copied, it can be taken away when an employee leaves. That's a problem. There are online tools such as LastPass and 1Password that you would be able to then restrict the access once that employee leaves. However, of course, they are exportable. So really, you have to evaluate your sensitivity to risk in this case, and set a policy for your company that fits your industry. In some industries, it's going to be decided that okay, we have our solid vendor remote access plan document. So that means that Joe engineer, when he leaves, he still can't hop on that E1 and get access to stuff anymore, because we know that Joe engineer's account is now disabled, so he can't get in there. Then we also know that okay, we have a bunch of passwords and we've been aggregated. That's how you log into all those systems. If they're Windows systems, really we should be talking about Active Directory. Even Linux systems, we should be talking about some sort of LDAP or director access control that can be turned off. If we're talking about other systems that cannot be enabled in that sense, where you have some sort of password for a project or for accessing a system somewhere, and that's what you have to store in a password manager, then by using a defense in depth type approach. So you've got multiple layers of access, you've got multiple protocol conversions, we call, as you're going through. So maybe you have a VPN or Citrix endpoint that then goes to a remote desktop server. And then from that remote desktop server, you leverage a tool to get onto your controls network and access those. So if you're able to shut off access at those various points, then you're going to very much limit the exposure of that employee's access later on. Now, in some industries, that is not enough, and that is perfectly acceptable. However, if you have all of these passwords and user accounts, really in those industries, hopefully you're leveraging directory access control and it's less of an issue. You're only talking about a couple of accounts that maybe you can't do that. But if that's the case, then when you have an employee depart or something change, then you need to go in and change those passwords. They should be flagged. There should be a policy in place for understanding what accounts need to be changed, whether they're, root accounts to switches or whatever, the sharing of those should be limited. And especially in the case of switches, really, you're using Radius. You shouldn't need to release that level 15 password to many individuals, if anybody. I hope that answered your question. Question number 2. are you seeing manufacturing companies start to adopt multi-factor authentication at the plant floor? Now, that is an interesting one. We are seeing a increase in multi-factor authentication. However, we're not talking about like the 6-digit code on your cell phone, per se. That's really not what we're seeing. But we are seeing, especially in life sciences, 21 CFR Part 11 compliance situations where we have to have, dual authentication. What we are seeing is a partner of Grantek's NIMI, which is it's a wristband. It looks just like your Fitbit. However, it has a unique, it uniquely monitors your heart rhythm, and it is able to use that as a digital signal for a second factor authentication in order to ensure that that user is who they say they are. They have a large number of controls on that. The band comes off, it resets, and needs to be recalibrated to the user, re-authenticated, et cetera, so they can ensure that that band is only able to be used by the user that it is supposed to be. Fantastic use of multi-factor authentication in a controls environment, especially because if you think about it, pulling out your phone on a shop floor, not ideal. Typing with gloves on, sometimes impossible. Key fobs and other things, they work okay in some instances, and we do see that, smart cards. However, really the benefit to the NIMI solution is that it's a wristband. It works through your lab coat, and it is very, very low requirement on the user, because that's really what you can secure a system to a point that it becomes unusable, and at that point your users are going to find ways around it. So something like this is really innovative, we find in the marketplace, and we're really excited to be using it. Question number 3: how do you enforce or set up vendor network so service companies and OEMs, when on-site, don't connect to your office network, or when they're not allowed? So that would be a kind of a multifaceted question there. When we're talking about the CPWE model, which whoever asked that question, if they want to reach out afterwards, I will certainly, I'm more than willing to kind of go through and talk through exactly the different levels and how you do that abstraction of layers. But basically, say you have cell A, which is a OEM machine, say it's a case packer, and that case packer, it needs to talk to some conveyors or something downstream or something upstream. So that case packer is on its own VLAN, and ideally you're taking that traffic up to a firewall or a device that has ACLs that can really limit the connectivity, and you're only allowing it to communicate where it needs to. So in that regards, you have your OEM. They are only authorized to plug in to their equipment, and they should not be able to. The basis of this is there should be no access from your controls network to your enterprise network in that direction. The CPWE and also the Purdue model show a demilitarized zone in between your controls layer and your enterprise layer. So that is probably step 1, critical to have. If you don't have that today, then there is a lot of potential data exchange and unwanted data exchange that could happen between those zones. So assuming that you have your cell 1 for that case packer, and you have your OEMs in there, then you could you could go so far as to do port security. So you have a grace port, and that is where the tech is allowed to plug in, and that is limited to only be able to access the machinery locally. So it can't even get up to the firewall. That's fine. That could be circumvented if they decided that they wanted to pull out the connection from the case packer and plug themselves in there directly. That's at that point, that's a policy violation. With the monitoring tools we're talking about, you could detect that with a change of MAC address or a power down, power back on a port. There's a bunch of different ways you could really track that, have an audit trail, show that that happened, and then you would be looking at policy violation and disciplinary action. But say that did happen, and then your next line of defense in this defense in depth philosophy is that, okay, so that case packer only could talk to 3 other devices. So even though this user is now pretending to be the case packer, he still can only talk to a couple other devices. He can't get to your enterprise systems. He can't get to your WMS. He can't get to your, SAP. He can't get to your desktops, your wireless, your any of that other stuff, because there's no reason for any device in that zone, in that cell, to ever have access to those things. So implementing a secure system with multiple layers of abstraction in order to protect that is really the key. And it's not an all at once kind of a thing. It is a design. It's an assess, design, and then assess your risk and implement slowly over time. That's really the process. It's a stepping stone. Think of it as climbing up steps on a maturity model in order to get where you want to be. You might, say it's a 5-step process. You might not want to be at step 5 today. Maybe you only need the functionality of step 2. But that's something that is an exercise to go through, understand what it means to get to each one of those levels as far as cost and as far as benefit, and then figure out where you and your company want to be. Question 4, how shall we apply cybersecurity in an industrial environment with Android user interfaces and Windows-based web interfaces and SQL databases? So let me think about that a little bit. So kind of a very broad question. So, you have maybe a BYOD policy. You're going to have, different systems, and Windows and Android, maybe Mac, etc. And then the next thing is a web interfaces to SQL databases. So if we're talking about kind of the front end user access, so I'm gonna spitball a scenario here, and hopefully it's, question 4, hopefully it's accurate to what you were looking for. You have an HMI or a reporting system. For this analogy, it really doesn't matter. HMI or reporting system, and you want to give a bunch of users access to that system. So they're going to access it with their iPhones, they're going to access it with their Android devices, with their Windows devices. That's one of your user requirements, is that it should be accessible on mobile, on desktop, etc. So the first part of that is that's your requirement. And when you get to the vendor selection part, you're going to have to choose a product or develop a custom product that supports that. For instance, inductive automation is an HMI product, as well as has a lot of MES and other ties, but it's HTML5 based. So it would satisfy that requirement of being able to be accessed by multiple different platforms. And there's plenty of other ones that also fit into that category. But basically, there is your access layer into that information, and then that system processes whatever it is on the back end. It could be reading tags over OPC. It could in the question it says SQL databases. So my assumption is that you've got some sort of data store, SQL Server, MySQL, Postgres, Historian, Pi, any of those things. But basically, you've got data on the back end, and you're expressing that through a visualization layer to the client. So it becomes a kind of a process by which you have to define what the entry and exit points are for each layer, and where your data is going to live and how you're going to access that. So question 4, hopefully that was what you were asking. Question 5, do we need to whitelist the applications and set them in read only? So again, this is kind of a general question, but this it's dependent on what your threat model is and what your sensitivity to risk is. So in some examples, maybe there is no IT staff, and there's really no ability to enforce this, and we're more concerned with, if you look at the top 20 CSCs, we're more concerned with figuring out what devices we have and what our software is. So right now, whitelisting applications is not really something that we're looking at. Now, on the other end, if you have the ability to do this and you have the maturity, you're on step 3 and you're getting there, then absolutely use whitelists. Use ACLs, access controls, in order to limit where these applications and users can write and read data from, because you get a threat that comes out and is able to compromise that user and execute, then it's going to have access to everything that user does. So of course, whitelisting and read-only access is going to limit the attack surface that threat can then access. Even if it's not an intentional threat, if it's a program that's misbehaving, or it's a user that's trying to do something not maliciously but just trying to get something done and being a little creative about it, you can really increase your resiliency by doing something like that. I find it very, very interesting that with I believe it was NotPetya would be able to copy itself to a computer, and then when it ran, it would initially run as the user context that it was able to copy over with. So whatever credentials it used to copy over there, it would execute as. Sorry, this was WannaCry. WannaCry. When it got onto that system, then it would execute. And generally, those users had network access, because almost all users have network access. So what it could do from there is it could spread. Not great, but it could spread. However, if that user was not an administrator on the system in which it landed, then WannaCry, it could not execute the crypto locking aspect of its process. So it would then have to take a second step in order to try to guess or hack or compromise the password and access to the administrative account before it could crypto lock that system. So because you've limited, in this case, not great, but you do have a limited user that doesn't have access to the root functions of the operating system, then all it can do is spread. It can't. So if you had an environment where there was, only execution at the user level, then they would all get this threat. However, it would not have crypto locked and destroyed any data at that point. Unfortunately, that wasn't the case, because generally you find holes otherwise. But that's I think a good example of where that would be beneficial. The last question I have, we've got a couple minutes left here, is I've heard that I need a pen test to find out where I'm vulnerable, and what should I look for, and what will they find? So going back to the CSEs again, if you look, and I will kind of hop back there real quick if I can get to it. Yep, too far. So penetration testing. Red team exercises. That is step 20. If everybody in this room, if half of the people in this room are at that point, then I would be excited. That would be amazing to see such a level of cyber maturity within our organizations. That would be great. It's a real buzz right now. Pen testing. That's what we need. They're going to tell us what we need to fix. Realistically, they're going to come in and they're going to ask you for your inventory of hardware and software. They're going to ask you for your network topology. They're going to ask you for those basic level. They probably are going to ask you for administrative privileges on a system or multiple systems, because the assumption is that the attacker or the malicious individual is going to have that or attain that within a relatively short amount of time. So why take a pen tester and make them try to figure out all of that stuff themselves when it's a guaranteed? Really, they're going to focus on the higher levels here in order to show you the value of what they're doing. So if you take them and you say, here's my passwords, we don't have any other controls beyond that, then they're going to take a nice easy check and give you some basic recommendations and move on. So it really behooves you to move up on this model, as far as you can, ideally to 19, and have all of these systems in place in order to really leverage the strength of what pen testing, ongoing pen testing can do for you. And if that is the extent of the questions that I have listed here. If there are any more, go ahead and send them over. I'll wait just one more minute, and I will flip to just my last slide here, which is just a little thank you with a nice little happy blob guy. And so if you have any follow-up questions, you certainly can send an email to info@grantek.com, and that'll get to our marketing group and myself, and we will be more than happy to help you with your journey. No more questions. So thank you guys very much for your time. I hope this was insightful. I hope you gained some interesting tools that you can leverage, as well as, you know, a little bit more insight into areas where major improvements can be made in conjunction with existing projects. Thank you for your time. Have a great day.